Alright, we're into the last section of polynomials, which is special products. Now, I'm not talking the special products that you get at the grocery store, like Fruity Pebbles and Mountain Dew, which would have been my ideal breakfast growing up as a kid. Although my mom wasn't too fond of that breakfast. Apparently there's too much sugar or something like that. And at least later on in life, I figured out that eggs and milk was a much better choice, especially since I wanted to play football and I needed that protein to build some muscle. And anyway, my wife, whenever she finds me trying to sneak that box of Fruity Pebbles in our grocery cart, she ends up throwing it out at the end, so can't even get away with it anyway. But let's look at the special products when we're talking about polynomials. Really looking at a product of two binomials. To start it off, there's going to be three special products with our binomials. Okay? The first two deal with squaring either a sum or a difference. And so algebraic terms, a plus b squared and a minus b squared. We'll do some examples to make sense of how these things work. And the last one is kind of the opposite of both those, is the product of a sum and a difference. So a plus b times a minus b. And if you can get these special products down, it saves you that time of having to go through the FOIL method or having to distribute. You can do some of these problems very quickly. So let's take a look at that first one, that sum of a square of a sum. Let's go through an example first so we can really understand why this square of a sum works. So we have 3x plus 5 squared. Okay, now this isn't our exponent property that we've done before. It's not like 3xy squared where I can just distribute that exponent. I can't distribute this square right here, okay, because of this plus sign. My exponent property is for a product and this is a sum. So I can't do that. I can't distribute that square. But if I look at it, what I can do is I can rewrite this. I can rewrite this as 3x plus 5 times 3x plus 5, right? Because that's what squaring means. We're just multiplying it by itself. And now if you look, we got a product of two binomials. So we can apply the FOIL method. First outside, inside last, or just distribute each term. So let's go ahead and distribute that 3x. 3x times 3x gives me 9x squared. And then 3x times 5 for a positive 15x. And then we do the insides, 5 times 3x, another 15x. And 5 times 5 for a positive 25. And let's go ahead and combine our two x's into a 30x. So we'll bring down our 9x squared plus 30x plus 25. And let's take a look at what happened here. If you look at going from 3x to that 9x squared right away, what really happened is we took this 3x and we squared it to give us a 9x squared. If you take a look at the last term of our answer, that positive 25, what we did was we took our second term of our binomial, 5, and we squared that. 5 squared to give us 25. And that was a positive 25. For that middle term, what happened was we got a 30x. How we got that was we took each term here, the 3x and the 5, and we multiplied them by each other. So 3x times 5, which gives us a 15x. 3x times 5, right? Take each term, multiply them, and then we ended up doubling that. So we take it times 2 to give us our 30x. So what that special product means is I take the first term, I square it. I take the second term, I square it to give us our ending. And for that middle term that we get is we multiply the two terms, the 3x and the 5, and we double it. Okay, so it's kind of confusing when we go through some examples. Hopefully it'll make some more sense. But let's look at that algebraically. So basically what this is a plus b times a plus b. And let's talk through how that worked. First term gets squared. Second term gets squared, but that's at the end. And it's a positive, so we have the plus sign in front. And for that middle term, what happens is we multiply the two, so a times b, and we double it. So a 2ab. So there is our special product for a square of a sum. So you just square the first, square the second, and then you multiply the two terms and double it. And that's all that happens with that. Looking when there's a subtraction symbol, only one part changes. Only one part's going to change. And let's talk about what will change here. So I have a minus b times an a minus b. Still the same thing. If I take our first term, let's look at our binomial squared here. We square, right? Like we talked about. We take a squared. Then we take our second term, which is a negative b now, right? A negative b, and we square that. Well, a negative b squared gives us a positive b squared, right? Because negative b times negative b is a positive, and it'd be b squared. So we get a positive b squared. And then when we multiply the two and double it, I'm going to take an a times a negative b, which gives us a negative ab, and then we double that, right? So we take that times 2, which gives us a negative 2ab. So all that happened between the two is that I have a minus sign here, and that's it, between the sum and the difference. So let's take a look at an example, and we'll do it both ways. We'll do the full FOIL method first, and then we'll go do and apply our special product so we can kind of see the difference and how much quicker it goes. So if I expand this out and take 3c minus 4 times 3c minus 4. Let's go ahead and distribute just like we did in that last section. So 3c times 3c, 9c squared. 3c times negative 4 gives me a negative 12c. Negative 4 times 3c, another negative 12c. And negative 4 times negative 4 for a positive 16. Now you can see why up top that ended up being a positive b squared. And then we simplify 9c squared, combine our two negative 12c's for a negative 24c plus 16. Okay, so that takes a little bit of work. Takes a little bit of work if we go through and use the FOIL method. If I use my special product, right, I got a square of a difference. All I got to do is square the first term. So I take that 3c and I square it. So basically I square each part of that. So I have 3 squared, which is 9, and c squared, which is c squared. So 9c squared. I take the second term, that negative 4, and I square that at the end. So negative 4 times negative 4 is a positive 16. And for our middle term, we multiply the two. So a 3c times the negative 4 for a negative 12c. And then we double that, right? We got to double it for a negative 24c. And there we go. And I got the exact same answer, right? And it goes a little quicker once you can just get that. So square the first term. So square the first term, square the second term, and for the middle, you multiply the two and double it. That's the only rule for that. And that works for both the square of a difference and the square of a sum, whether it's a minus or a plus sign. Works the exact same way. Our last one is when we have a sum and a difference, okay? And if you notice, we have the exact same terms in the same spot. So the 2x squared, a plus 3, and now a minus 3. And it's just a plus and a minus is the only difference. But we got 2x squared, and a 3 and a 3. So let's go ahead and apply the FOIL and see how this is going to work. So we got 2x squared times 2x squared for a 4. Remember, it's just x times x times x times x to give us x to the 4th, where we add the exponents. And then we have a 2x squared times a negative 3 for a minus 6x squared. And then to the insides, 3 times 2x squared for a positive 6x squared. And 3 times negative 3 for a negative 9. What you should notice there, and that's what makes sense. We have the different signs. It ends up canceling our middle terms, right? I got a negative 6x squared and a positive 6x squared. They cancel with each other, right? They're opposites. So all I'm left with is 4x to the 4th minus 9. 4x to the 4th minus 9. So let me rewrite this up here. I had 2x squared plus 3 and 2x squared minus 3, and we're multiplying them. So all that really happened was, if you take a look at our first term, that 2x squared, what happened was we just squared that. Okay? And our second term, we squared that as well. A 3, right? We squared that 3. So we had a 4x to the 4th and a 9. And you got to think about what sign would go in there. Well, is this 9 positive or negative? If you look back here, we took a 3 times a negative 3, right? 3 times a negative 3. That's why we get a minus 9 and not a plus 9. Okay, so if you have a sum and a difference with the exact same terms, all that's happening is I square the first term, a squared, square the second term, b squared, and we get a minus sign in between it, because a b times a negative b is a negative b squared. And that's all you got to do. So let's apply these special products with some examples. So look at the first one. I got the square of a sum. So remember, square the first term, square the second term at the end. It's a positive 25. And then we multiply the two. So 5 times an x is a 5x. And we double it for a positive 10x. And I'm done. Same thing with the next one, except we just got the minus sign. So I square the first term. So 11 squared is 121. Square the second term. Negative a times a negative a is a squared, right? A positive a squared. And then 11 times a negative a is a negative 11a, right? Negative times a positive is a negative, and 11 times a is 11a. And then we double it for a negative 22a. And I could write that in standard form and put my highest degree out front, but that's okay for now. This is okay for now. Just a couple more. If we look here, 2x plus 7y times 2x plus 7y. It's just written different. This is really a square of a sum, isn't it? These are the exact same things. I could rewrite that as that. Okay, so I take then our rule. Take the first term, we square it, so 4x squared. Take the second term, we square that at the end, so 49y squared. And then we multiply the two, so 2 times 7 is 14, and an x and a y. And we double it for 28xy. Oh, I'm going to back this up a little bit. Good. So if it's a square of a sum or a difference, if we're just squaring the exact same binomial, that's all you got to do, right? Square the first term, square the second term at the end, multiply the two, and double them for the middle. And then lastly, when they're opposites, this is probably the easiest one. We square the first term, so 9m squared. Square the second term. 4 times 4 is 16. And what sign should we get? Minus, right? Because we have a positive 4 times a negative 4 at the end. And our middle terms end up canceling if I'd actually go through the FOIL, and that's why I can use that special product. Okay, so hopefully you'll be able to see those special products when you're going through these, and it should save you some time rather than having to go through the FOIL. And if you have trouble or you want to check your answers, go through the FOIL and make sure that you got your answer right. All right, thank you.